Hi everybody, today we are going to be learning about the precalculus function graphs. This video will consist of three parts. The first is a review of function graphs and their properties. The second will be an application problem, and lastly we will fit 4 different equations to the 4 different kinds of function graphs. So as you can see here, I have listed the 4 types of function graphs. The first is a linear and or constant graph. The second is a quadratic. The third is a power function, and the fourth is an exponential function. So a linear and constant function is always in the form of a straight line. If it is not straight, it is definitely not a linear or constant graph. This can be written in 2 ways: y equals mx plus b, or f of x equals ax plus b. And in the first instance, the m represents the slope. In the second instance, the a represents the slope, which you know from algebra 1 can be found by the change in y over the change in x, rise over run. And the b, in both situations, represents the y-intercept, which is where the line crosses this vertical axis here. Second, we have a quadratic function, which looks sort of like a parabola. And this also can be written in 2 different forms. The first is standard form, which is f of x equals ax squared plus bx plus c. And when looking at this, you will definitely want to know that the vertex can be found by minus b over 2a, and then taking your solution to that and plugging it back in. So f of negative b over 2a, and 0c will get you your y-intercept. Aside from standard form, we also have vertex form, which is y minus k equals a times the quantity of x minus h squared. And in this instance, the vertex is h minus k. Now we have a power function, which looks like this. And there's only one way to write a power function: y equals ax to the b. And a couple properties of this graph that are important to note is that when b is greater than 0, when it's a positive number, the graph contains the origin. So it contains 0, 0. And when b is less than 0, or when it is a negative number, we are going to have 2 different asymptotes, one on the x-axis and one on the y-axis. Next, we have an exponential function, which can be exponential growth, as shown here, or we also might have exponential decay, as shown there. Now, this also has one way to be written: y equals ab to the x. And this is oftentimes confused with a power function. However, you can tell the exponential function is in fact exponential because there is an x in the exponent. And you'll want to know that when a is less than b is less than 1, you have exponential decay. And when b is greater than 1, you're going to have exponential growth, which is shown up here in the graph. It's concave up. Here we have a little application problem that states that 2 airplanes are flying in the air. At the time 0 equals the time in minutes, the planes are 17 miles apart. At time t equals 4 minutes, they reach their closest point of approach, 5 miles apart. Thereafter, the distance between the planes increase. And this problem wants us to write an equation in vertex form of the quadratic function expressing the relationship between the distance and the time. And it wants the equation in a form such that the distance is expressed as a function of time. So the question gives us two different points. It gives us 0, 17, and it also gives us 4, 5, which you notice are written in the form of minutes or time and miles. So the x is always the time and y is always. And as you can see, we have a vertex of 4, 5. So if you can remember from this last slide, we have the equation in vertex form, y minus k equals a, x minus h squared. And we are going to plug in our hk, which is 4, 5. So we are going to have y minus 5 equals a x minus 4 squared. And our goal here is to solve for the a, which can be done by plugging in other points for x and y. And luckily, we do have another point for x and y, 0, 17, which we will be plugging in. So we have 17 minus 5 equals a times 0 minus 4 squared. We are going to solve for the a, which is 3/4. Now from here, it's smooth sailing. We are going to say distance as a function of time equals 3/4 times t minus 4 squared plus 5. And we have a plus 5 here just because we are moving that to the other side, as in plus k. And that is going to be helpful for our next two parts of the question. Here we have how far apart were the planes when t equals 7 minutes. And as you remember from the first question, we have minutes and then miles. So the time is going to be the x and the distance is going to be the y. Our equation from the previous problem was distance as a function of time is 3/4 t minus 4 squared plus 5. And we are going to plug in 7 for our t. So when the distance is, when the time is 7 minutes, we are going to have 3/4 7 minus 4 squared plus 5. And that is going to get us 11.75 miles as our distance. Next, we have at what time were the planes first 10 miles apart? So now they are giving us 10 miles, which is our y, or our distance as a function of time. So we are going to plug that in for the left side of the equation. And we are going to subtract 5 because we are trying to isolate the t. And once we have 5 is 3/4 t minus 4 squared. To undo this, we are going to multiply by 4/3 on both sides of the equation, which will cancel those out and give us 20/3 equals t minus 4, the quantity squared. And we can undo the squared by taking the square root of both sides, which is going to give us 4 plus or minus the square root of 20/3. This is a quadratic, so plus and minus will give us two answers. T is 1.42 minutes and t is 6.58 minutes. We're going to take the lower of these two, which is time equals 1.48 minutes, which is equivalent to 1 minute and 25 seconds, and that is going to be our final answer. For the next part of this video, we are going to be fitting equations to the four types of function graphs. This graph here is a linear function. That means you're going to use the equation y equals mx plus b. So the first step in this is finding the slope, which is the change in y over the change in x. So in this instance, it is going to be 13 minus 25 over 8 minus 3, which simplifies down to negative 12 fifths. Negative 12 fifths. It's going to be our slope. Then we're going to plug this into point slope form, which, as you remember from algebra 1, is y minus y1 equals mx minus x1. And we're going to plug this in for the m along with another set of points for our y1 and y2, or y1 and x2, sorry. And you are going to get y minus 25 equals negative 12 fifths x minus 3. And that is going to be our point slope form of the equation. You could also turn it back into the y equals mx plus b form just by multiplying negative 12 fifths times x and times the negative 3 and then adding 25 to the right side of the equation. Next, we have an exponential function. It is important to note that this is exponential, and you can tell because it only has one asymptote, asymptote being the x-axis. All right, so now that we know 2 points on our graphs, we are going to take our equation y equals ab to the x power, and we are going to plug in both of these points to this equation, x and y. So we are going to have 4 equals ab cubed and 9 equals ab to the 8th power. Now, it doesn't matter which one of these equations you do this with, but you're going to want to solve one of them for the a. So I'm going to solve this top one for the a, and I'm going to get a equals 4 over b cubed. Now, once I have this a, I'm going to want to plug it in to the other equation. So I'm going to get 9 equals 4 over b cubed times b to the 8th power. Another way to write this is 9 equals 4b to the 5th. Now, since we want to solve for the b, we're going to divide both sides by 4 and get 9 fourths, the 1/5 power, equals b. Now that we have b, we are going to plug that back in to this equation up here so we can solve for our a. So we would have a equals 4 over, and I'm going to use the b as 9 over 4 to the 1/5 times 3. And this is going to yield an answer of a equals 2.459 if you solve this out with a calculator. Now, since we have both our a right here and our b right here, we are going to plug this into our equation. So we're going to have y equals 2.459 times the decimal version of b, which is 1.1176 to the x. And that is going to be our equation for the exponential function. Now here we have a power function, and it is important to differentiate this with the exponential function. A power function has two aspects, both at the y-axis and at the x-axis. Now, our process for finding an equation is very similar to the one we used for the exponential function. We are going to take y equals ax to the b, and we are going to simply plug in the points. So we are going to have 15 equals A, 3 to the B. We're also going to have 2 equals A, 6, 2 equals A, 8 to the B. Now we're going to solve one of these equations for A, and I'm going to use this bottom equation here. So I have A equals 2 over 8 to the B. And I'm going to, as we did in the previous, plug this in for A. So I'm going to have 15 equals 2 over 8 to the B times 3 to the B. And you can rewrite this as 15 equals 2, 3 over 8 to the B. Solve both sides, divide both sides by the 2, and you are going to get 15 over 2 equals 3/8 B. And kind of a review from Algebra 2, we are going to use logs to undo this. So we'd have the log of base 3/8 to the 15 halves equals B. Now you can usually just plug this in on a calculator to get B, which equals negative 2.054. But if your calculator does not let you have a base other than 10, you would take the log of 15 over 2 divided by the log of 3 over 8, both of those with a base of 10. So now that we have our B, we are going to plug it back in over here. So we're going to have 2 over 8 to the negative 2.54, and that is going to give us A equals 143.21. Now that we have our A and our B, we're going to plug them back into the form y equals ax to the b, which is ultimately going to give us y is approximately equal to 143.21 x to the negative 2.054 power. And lastly, we have a quadratic here. Again, you can talk quadratic because it looks like a parabola. And we are going to use the form y equals ax squared plus bx plus c. Solve this. This one is probably our lengthiest of the 4 power functions. We are going to start out by plugging in the coordinates for the y and the x. So that is going to give us 26.6 equals 9a plus 3b plus c. So check. Then we're going to have 38.6 plus 60 equals 64a plus 8b plus c. And lastly, we are going to have 13.4 equals 196a plus 14b plus c. Now, the goal of writing it out like this is to solve for each of the variables individually. And we're going to cross out one of the variables. It's the simplest to do this with c because they all have a coefficient of 1. We're going to subtract the second equation from the third equation and the first equation from the second equation, which is going to yield negative 25.2 equals 132a plus 6b, and 12 equals 55a plus 5b. So now that we have these, we are going to want to cross out the b. And the easiest way to do this would be to take this times 6/5, cross out both of the 5's, they cancel, and then you will just have with a 6. We're going to have to distribute the 6, and you are going to get 14.4 equals 66a plus 6b, and the bottom equation, of course, stays the same because we are not doing anything to manipulate it. Now we're going to subtract both of these equations from each other, and we are going to get negative 39.6 equals 66 equals 66a. Okay. Now we're going to divide both sides by 66, so we would have negative 39.6 divided by 66, and that is going to give us a equals negative 0.6. All right, so now that we have our A, it's pretty much smooth sailing from here, we're going to plug that back into one of these equations up here to give us our B. So I'm going to plug it into, let's see, 12 equals 55 times negative 0.6 plus 5b, and that is going to simply give us b equals 9. Once we have the a and the b, we can plug it into one of the equations over there. If you plug it into the first one, or in fact any of them, you're going to get c equals 5. And now that we have a, b, and c, we're going to plug them into our quadratic, and that is going to give us y equals negative 0.6 x squared plus 9x plus 5. And that is it.